Arrays show up everywhere in TypeScript interviews and real projects. In this video, we will solve 20 practical array challenges with clear inputs, outputs, and explanations. If you are a beginner or junior developer, these are the problems you need to master. We start with the array methods you will use in almost every TypeScript interview and real application. Each task uses typed data, a small practical scenario, and a terminal result you can verify immediately. A dashboard often receives many users from an API, but only active users should appear in the UI. We define a user type, create a typed users array, keep only records where isActive is true, and then collect their names. Now let's run the script and look at the output. Let's break down why this works. Filter checks each user and keeps only the objects where the predicate returns true. After that, map turns the remaining user objects into the final list of names. Now we show the safer version to remember. Give the array an explicit user type because then TypeScript protects property access inside filter and gives useful autocomplete while you write the predicate. For practice, add a role field to each user. Then change the filter so the dashboard shows only users who are active and have the admin role. An e-commerce page may store base prices, but display prices with tax included. Here we create a product type. Keep the source data simple, and use map to return a new object for every product. Now we run it and check that each product has the computed price with tax. Let's break down the result. Map visits every product and builds a new value for the new array. The spread operator keeps the existing fields, and price with tax adds the computed display price. Now we show the better habit for production code. Return new objects from map instead of mutating product inside the callback, because immutable transformations are easier to debug and safer to reuse. For your variation, add a discount % field, then map the products into a new array that includes final price after tax and discount. A store admin may want to highlight the first product above a configured threshold. We use find because we only need one matching item, then we create a safe message for both cases. Now let's run the script and see which product is selected. Let's break down why this is interview safe. Find stops at the first product where the price is greater than the threshold. Because find can return undefined, the conditional expression prevents us from reading name from a missing value. Now we show the important habit. Always treat the result of find as possibly missing, especially in TypeScript projects with strict null checks enabled. For practice, change the threshold to 500. The product list will no longer contain a match, so your code should print the fallback message instead of crashing. Before checkout, the app needs to know if every requested item is actually available. We model each cart item with quantity and stock, then use every to validate the whole cart in one readable line. Now we run the script and check the Boolean result. Let's break down the result. Every returns true only if the callback is true for every item in the array. The last item has quantity 1 but stock 0, so the full validation becomes false. Now we show the best way to express this intent. Use every when the business rule means all items must pass, because the method name matches the rule and avoids noisy manual loop code. For practice, update the stock for HD03 from 0 to 1, then rerun the same validation and confirm that the cart can now be checked out. A security system often needs a quick yes or no answer. Did any login come from a blocked country? We create login attempts, define a blocked country list, and use some to detect if at least one attempt matches. Now let's run the script and inspect the result. Let's break down why the output is true. Some checks items until one callback returns true. The RU login is in the blocked country list, so the method can answer yes without needing the exact matching object. Now we show the best rule of thumb. Use some when the question is whether a match exists. If you need the actual item, switch to find instead. For practice, make the security rule stricter. Mark a login as suspicious only when the country is blocked and the login attempt failed. In this section, we use arrays to calculate totals, build groups, and count repeated values. The goal is to make reduce feel practical instead of abstract. An order service often needs to calculate revenue from completed orders. Let's model each order with a status and a total, filter out canceled orders, and then reduce the remaining totals into one number. Now we run the script and look at the final revenue printed in the terminal. Let's break down why this works. The canceled order is removed before the reduction starts, so it never affects the sum. The accumulator begins at 0, then adds 120, 89.5, and 226, giving us 435.5. Now the best practice, always give reduce an initial value when you're calculating a number. It keeps the accumulator type clear, and it also prevents surprises when the array is empty. Use 0 for sums, an empty object for lookup maps, and an empty array when collecting values. For practice, add a refunded status to the order type, then add one refunded order and update the logic so only completed, non-refunded revenue is counted. This is the same pattern, but with a slightly more realistic business rule. A project board needs tasks split into Todo, in progress, and done columns. Let's define a status union, create the initial buckets, and use reduce to push each task into the right array. Now we run it, and the terminal shows the grouped board data. Let's break down the algorithm. The initial object already has every allowed status as a key, so reduce never has to invent a bucket while looping. For each task, task status selects the correct array, and push adds that task to the matching group. Now the best practice, use a union type for the allowed group keys. This is better than a loose string because TypeScript can catch a misspelled status before the code runs. Apply this whenever your groups come from a fixed set of values. For practice, add a blocked status to the task status union. Then add one blocked task and update the initial group's object. TypeScript should guide you to every place that needs the new status. A blog platform may need to show the most common article tags. Let's flatten all tag arrays first, then reduce the flat list into a frequency map. Now we run the script and see how many times each tag appears. Let's break down why the result looks like this. The first post adds TypeScript and arrays, the second adds React and TypeScript, and the third adds testing, TypeScript, and React. Every time reduce sees the same tag again, it increments the existing number. Now the best practice. Separate flattening from counting when the data shape is nested. It makes the code easier to inspect, and each step can be tested on its own. Use this approach when one line would hide too much logic. For practice, convert the frequency object into entries and sort them by count descending. The goal is to produce the tags in popularity order, not just insertion order. This turns the aggregation into something a UI can display directly. In this section, we remove duplicates from real data. The important part is choosing the comparison value before we deduplicate. A newsletter import often gets emails with extra spaces and inconsistent casing. Let's trim each email, lowercase it, and then use a set to keep only unique normalized addresses. Now we run the script and the terminal prints the clean list. Let's break down the result. The two Alice values become the same lowercase address, and the two Bob values also become the same normalized string. Set compares those normalized strings, so only one copy of each address stays in the array. Now the best practice, normalize before deduplicating. This is better because users and CSV exports often represent the same value in slightly different ways. Apply this to emails, usernames, tags, and any text where casing or whitespace should not create a new value. For practice, add a value like not an email to the input. Then filter the normalized array so only strings containing an @ sign and a dot are passed into the set. Keep the validation simple here. The goal is to practice the array pipeline. A client app may merge users from multiple API pages and receive the same ID more than once. Let's store each user in a map keyed by ID, then convert the map values back into an array. Now we run it and the terminal shows one user object per ID. Let's break down the behavior. A map can only store one value for each key, so setting U1 a second time replaces the earlier U1 object. In this version, the later API page wins because we always call set for every user. Now the best practice, deduplicate objects by stable identifiers, not by object references. Two separate objects can describe the same user, but JavaScript will still treat those object references as different values. Use IDs from your domain model whenever they exist. For practice, change the map loop so the first user wins. Before calling set, check whether the map already has that ID. This small variation is important because real products need to choose which duplicate is trusted. In this section, we solve array sorting problems that show up constantly in real apps and interviews. We will sort typed objects by dates, numbers, and tiebreaker rules. A changelog page needs releases from newest to oldest, but API data is not always ordered. Let's write a typed release array, copy it with the spread operator, and sort the copy by parse date timestamps. Now we run the script and check that the printed release names are in descending date order. Let's break down why this works. Date.parse gives us numbers. So the sort comparator can compare real-time values instead of guessing from strings. When the result is negative, the first item moves earlier. When it is positive, the second item moves earlier. Here's the best practice for date sorting. Compare timestamps, not raw date strings. This is clearer, works well with typed objects, and avoids hidden assumptions if the date format changes later. Now try a small variation yourself. Add another release dated March 1st, 2025, and make sure it becomes the first printed item. This checks that your comparator is really sorting by date, not by the original array order. A leaderboard cannot leave tied players in a confusing order. Let's sort the players by score descending, and when scores match, use the name as a second rule. Now we run the script and the tied scores should still appear in a predictable order. Let's break down the ordering. The first comparison handles the main ranking rule. Higher score wins. Only when that result is 0 do we move to the second comparison, which sorts the names alphabetically. The best practice here is to make every tiebreaker visible in the comparator. That makes the result stable for users, tests, and future developers reading the code. It also prevents random-looking ordering when two records share the same main value. For practice, reverse only the tiebreaker. Keep higher scores first. But when two players have the same score, print the name that comes later alphabetically first. This is a good test of whether your primary and secondary rules are separated. Now we move to slices. These problems are practical because pagination and batching are everywhere in APIs, dashboards, and search interfaces. A search UI needs to show one page at a time instead of dumping every result. Let's create a reusable getPage function that calculates the start and end indexes, then uses slice to return only that range. Now we run it for page 2 with 2 items per page and look at the output. Let's break down the math. Page numbers usually start at 1 for users, but array indexes start at 0. So page 2 with size 2 starts at index 2 and slice stops right before index 4. The best practice is to keep pagination as a pure function. It should receive an array, page, and page size, then return a new view of the data without changing the original list. That makes pagination logic simple to test. Now try requesting page 3 with the same page size. You should get the last 2 results from the list, if you do your start and end calculations are correct. An integration might only accept 3 IDs per request, so we need to split a longer list into small batches. Let's write a generic chunk array function, move through the array by the requested size, and slice each batch. Now we run it and print the nested arrays. Let's break down the loop. The index starts at 0 and increases by the batch size each time slice returns up to 3 items. And the final slice can be smaller when there are not enough items left. The best practice is to make this kind of utility generic. With chunk array T, TypeScript keeps the element type, so number arrays return number batches and string arrays return string batches. That gives reusable code without losing type safety. For practice, reuse the same function with email strings instead of IDs. Set the chunk size to 2 and check that the return type is still an array of string arrays. This is the point of the generic type parameter. This final section handles nested data. The goal is to turn grouped records into one useful array without writing unnecessary loops. A moderation queue should not care which post each comment came from at first. It needs one flat list to review. Let's create typed posts with nested comment arrays, then use flatmap to collect every comment text in one pass. Now we run the script and check that the output is one flat array. Let's break down why flatmap is a good fit. Each post can produce many comment texts, one comment text or no comment texts. Flatmap collects those arrays and flattens exactly one level into the final queue. The best practice is to reach for flatmap. When one input item can become multiple output items, it keeps the transformation readable and avoids temporary arrays or nested loops for simple one-level flattening. For practice, keep the flattened structure, but include the post title next to each comment text. That variation is useful when a moderation queue still needs to show where each comment came from. Now we move into nested and derived array data. These examples are about turning structured objects into values a UI can use directly. A product page often receives category data as an array of path segments. Let's write the data once, then derive both a readable breadcrumb and a URL path from it. We map labels for the UI, filter empty slugs for the route, and now we run the script to check both outputs. Let's break down why this works. The breadcrumb uses the label field, because that is what the user should read. The route uses only non-empty slugs, so home can appear in the breadcrumb without adding an extra empty URL segment. Now we show the best practice for this pattern. Keep labels and slugs separate whenever data is used for both display and routing. That way a copy change like electronics becoming tech does not silently break links. Try a small variation yourself. Add a fourth segment for lenses, then confirm the breadcrumb and URL both included in the correct order. This section focuses on arrays that look like real application data. We will merge records, validate imports, and keep the output structured. Warehouse data usually arrives as two arrays, what we already have and what changed. Let's build a map by SKU, then apply each update without scanning the whole inventory every time. Now we run it and inspect the final inventory. Let's break down the algorithm. First, the current inventory becomes a map where the SKU is the key. Then each update either changes an existing quantity or creates a new item, so the merge stays clean and fast. Now we show the best practice for bigger datasets. Index one array by a unique key before merging. This is the difference between code that works on a demo and code that still works when inventory has thousands of rows. For practice, change the update object so it stores the final quantity instead of a quantity change. Then rewrite only the update loop and keep the map-based merge. CSV imports are messy, so our code needs to separate clean rows from rows the user must fix. Let's validate the SKU and quantity, then reduce the input into valid rows and error objects. Now we run it and check that both outputs are easy to read. Let's break down why reduce fits this task. We are not just mapping rows into another shape, we are partitioning them into two different arrays. Each row either goes into valid rows or errors, and the final object is ready for the UI. Now we show the best practice for import validation. Return structured errors for expected user mistakes. Throwing is better for system failures, but invalid CSV rows should be reported clearly and continue processing. Try adding one more validation rule. Detect duplicate SKUs and put the later duplicate row into errors with a clear reason. Now we finish with algorithmic array problems. The goal is to scan arrays efficiently while keeping the code readable in TypeScript. Analytics dashboards often need a rolling average, like active users over the last 3 days. Let's implement this with a sliding window and a running sum. Now we run the script and expect 3 averages from 5 input values. Let's break down the result. The windows are 10, 20, 30, then 20, 30, 40, then 30, 40, 50. Their averages are 20, 30, and 40, and we get them without summing each full window again. Now we show the best practice for this algorithm. Use a running sum for moving averages when the window moves one item at a time. It keeps the function on instead of doing repeated work inside nested loops. For practice, make the function round each average to 1 decimal place. Then test it with values like 10, 11, 14, and 20. A fitness app might want to find the longest run of improving daily step counts. Let's scan the array once and remember both the current streak and the best streak. Now we run the script and print the length plus the actual values. Let's break down the scan. When the next number is larger, the current streak grows. When it is not larger, the current streak starts over, and whenever current beats best, we save that position. Now we show the best practice for streak problems. Track only the state you need, where the current streak starts, how long it is, and the same 2 values for the best streak. That keeps the solution simple and linear. For the final practice, change the rules so equal numbers still continue the streak. That means replacing strict increasing with non-decreasing and testing data with repeated values. Now you have 20 TypeScript array patterns you can reuse in interviews and real code. Like the video, subscribe to Dev Level Up, and write in the comments which TypeScript topic or challenge set you want next.